Thank you to be there, even it's early and some of you have perhaps a longer metro time, travel time with a crowded metro. But we are now to see this session on SRTI, and we will begin with a cooperation we had, and we will continue during NAPCOR with TISA. TISA, Traveler Information Services Association, is executive director, is there, Matthias Hunbaum. He worked there since years now, if I can say, and he knows perfectly the Traveler Information Services because so TISA is also to maintain some standards like TPEG, and that is the reason we are working together, because that text, as we see yesterday, is to exchange among road operator, but after TPEG and TMC, AlertC is used to provide this information to the driver, what is important, because the driver has to take into account what we want to say. I leave you the floor, Matthias. Thank you.
Okay, well, thank you. That saves me a lot of introduction because, I mean, as Jean-Philippe said, I mean, the information has to be distributed eventually and inform the drivers, and that's what we take care of. So, also from my side, good morning. Thanks for showing up at this early time. For those of you who are not familiar with TISA, a quick sort of introduction. TISA was started in 2007 as a merger of the TMC forum, the TPEG forum, and the Mobile Info project, where for the first time TPEG technology was actually put into a car and tested out on the road and deemed sort of useful, and then sort of within TISA the work on TPEG version 2 started, which is now the go-to standard if it's about traffic information and dissemination of traffic information into navigation devices. However, I would like to point out, even if now we work mostly on TPEG, that's what keeps us busy at the moment, and TMC is, yeah, you could say it's in kind of a maintenance mode. It doesn't mean that TMC has disappeared. It's still going strong. It's still in some markets the bread and butter business. Yeah. So I want to make a point here because I very often hear these statements, oh, we have this wonderful new thing and it'll replace everything that existed so far, and it's the one size fits all and it solves all the problems. This is rarely the case. I mean, we still maintain TMC. It's still widely used in millions and millions of devices, even though if now our attention is on TPEG, and many, if not all, service providers actually have both feeds. So they have, sometimes in the same market, TMC services and TPEG services. Good. Our membership ranges all the way from public authorities, road operators, over content providers, service providers, device makers, all the way to the OEMs. We have a global membership, so we're not focused on Europe. We have quite a strong membership in the US, for example, and in the Far East. And in this small map inset, you see the countries where TPEG services are available, and you see it's pretty much covering the relevant markets. Good. What is this animal called TPEG? Actually, we talk about TPEG version 2 here. The version 1 was quickly abandoned because it was too convoluted, too complex, not well structured for use in navigation devices. So it's actually not a monolithic standard, it's a set of standards, and you can almost combine them in any way you wish. There are some baseline components that you need. It's like the management container and the location referencing container. But apart from that, you can mix any kind of standards and create any kind of service bouquet to your liking. Why does traffic event compact stick out here? Well, okay, it's the most favorite. I mean, I dare to say all service providers have it. But this is also the sort of the baseline from which the safety relevant message set was extracted. So now in the following slides, if I talk about TPEC in relation to SRTI, this is about tech. So tech can be used to encode all sorts of road-related incidents. Don't want to go into the details. I think the picture tells it all. Good. Besides developing and maintaining standards, we do quite a few other things. So we issue position papers. I will dwell on that in a minute. We work on quality topics. We're in the moment quite busy modernizing TPEC 2 and gearing it towards CI/CD, continuous integration, continuous deployment. We set up our own GitLab server, and we're now moving TPEC 2 to a protobuf-based serialization scheme where we almost with the push of a button from the UML model can create the protofiles, and they can be then used and sort of used for the integration in all sorts of programming languages. There's a wide array of tooling available. It's open source, and so we ran some initial tests, and to our surprise, when comparing the protobuf serialization to the, say, handcrafted sorting bits and bytes, where you have a kind of a priori domain knowledge, which protobuf doesn't have, the performance is quite good. So we talk about a bandwidth expansion of maybe in a range of 20%. And the feedback we get from the service providers and the OEMs is this is not a big deal because it's overcompensated by the efficiency gains, the speed of deployment, the ease of implementation, reduction of programming errors. So, I mean, they talk about an order of magnitude speeding up this whole deployment process. And so the 20% additional bandwidth, that's something they can easily cope with. Good. We also enjoy a range of liaisons with all sorts of other organizations. You're probably quite familiar with them. And then we started looking into, safety-related things that don't originate from traffic, so it's not about accidents and stuff like that, but that actually impact on traffic. And at the end, I have a few slides on that, so I'll dwell on that. And the last point, we just submitted a standard to ISO now, DRR, driving restriction regulations, which is exactly about what we talked about yesterday in context of meter and UVAR, and hence my interest in these presentations. So now this has been submitted to ISO. It's in the balloting process now. I kind of sense a need that we may have to look through DRR again in the light of the findings from UVAR and the ongoing developments with meter. I spoke to John Harrod Booth yesterday, so we need to do our homework and revisit the DRR, and maybe we look at a DRR version 2 harmonized with UVAR box and meter sometime down the road. Good, but let's jump on to SRTI, if that thing starts moving. I hope I didn't break it. Can you put the focus back on the presentation? Because I see I'm moving through the file manager here. Cool. No worries. Well, you probably know the history. Delegated Act C in 2013, followed by the Delegated Act B in 2015. I'm not telling you any news here. Well, we already started 1 year early in 2012 during the what's it called? I lost my words. Public consultation process. We issued a position paper. By the way, it's available on the website, so you can go there, download it if you care to read it, where we proposed a set of 7 categories that we deem useful in context of SRTI. The European Commission then came back to us and said, well, we would like to add we would like to have the exceptional weather added as well. So in the end, it became 8 categories. And yeah, then in 2013, we set together a group in the Blue Tower. I think Josef was there. I don't know, Bart, if you were there. It was Toyn Hendrik, so a small group, and we started looking at, okay, what are relevant messages in the different standards that we can propose to be used in context with SRTI. So this is the tables we came up with. Just be a bit careful. It's not a translation table. Yeah, you can't go like left, right, and translate from one standard to another, because yeah, you see they're like, it's not a one-by-one mapping. It's in some cases actually a one-to-many mapping. Yeah, you see here, aquaplaning, surface water maps to actually 2 different events in TMC. And if you look here, it's ice on road maps to ice and icy patches, and here again ice and icy patches. So this is actually the reason why we came up with this table, to remove these ambiguities. Yeah, to say, okay, if it's an incident of that type, this is what we propose, how you should encode it in DATEX2, how you should encode it in TMC, and how you should encode it in TPEC2. But you can't flip it around and say, okay, I can take this table and translate forth and back between the standards. That won't work. It may work in some cases, but eventually you'll run into trouble. Good. Yeah, we started with 10 to 15 events. In the end, it got to 51, which we believe is still manageable, but our intention is to keep it small and manageable. Good. 2017, second version, we added the denim messages, which was a bit tricky because denim is not sort of, doesn't have the coding breadth and depth, so it required some workarounds in some cases, but we managed to include it. So now you can take this document, and by the way, it's also available on request, and look how the different message categories can be encoded also in denim besides the other 3 standards. Good. Action B. You may now kind of expect, okay, and next year we're going to publish the document about Action B. This is not going to happen. action B is a different animal. It has a much wider scope, and we as TISA think that it's important to have a harmonized and agreed upon message set for the safety related stuff, because I mean, this is about severe things. It needs to go quick. There shouldn't be any ambiguity. There shouldn't be any discussion. How do I do it here? How do I do it there? I mean, it should work out of the box. B, to its much wider scope, like, for example, traffic management, parking, etc., is not addressed in C. B is more onto kind of not predictable, but I mean, not as severe and unpredictable events as C. So we have no intention to produce a similar document on B just because the scope is too wide, and I don't think this is leading anywhere. Good. Besides the actual technical work on this harmonized message sets, we also spent quite some time on the declaration of conformance. And again here, B and C are two completely different animals and need to be treated in different ways. So we proposed these declarations of conformance that service providers can use to declare their conformance to the member states. It was a quite lengthy discussion, but in the end we came up with a good proposal that seems to work for everyone. Yeah, version 3. Of course, requests keep coming in. Oh, can we add this? Can we add that? And there are specific cases in each of the member states, and they all want to be included. And well, as I said earlier, we want to keep it concise and slim and manageable. It should not be a wish list where everyone can come and say, oh, I want to put this item on the SRTI harmonized message list. So we're quite restrictive in a way. So we had requests to add 90 additional events. In the end, 10 made it into the document. Yeah, again, this is not kind of prescribing anything. This document should be seen like implementation guidelines or best practices or whatever you want to call it, but it doesn't have any legal power. You can use it or you do something else. Yeah? So it is really to aid the implementation of SRTI services. It's not prescribing it in a way, this is the one and only way to do it. Of course, preferably if as many as possible stakeholders follow this recommendation, but it's not legally binding or prescriptive that you have to do it this way. So it's actually up to the member states to decide. Good. Key takeaways. The most important learning that we had from this quite long process is B and C are, even though at first glance they look similar, it's two completely different things and they need to be treated differently. Even though they sound so close, yeah, it's under the same EU regulation and it's B and C, it's very close, it can't be that far apart, but if you look closer, it's not. It needs to be treated differently. Because I just noticed that there's an off missing between responsibilities and actors. I mean, the impact on the stakeholders is quite different. So I already pointed that out. We want to keep the recommended message set for C as slim and small and manageable as possible. However, we noticed that handling B and C may be a challenge, so our proposal is you run, if you run both services, that you have C, keep it slim, keep it focused, and then sort of overlay the B to provide a more comprehensive traffic situation. Good. I promised you to dwell a bit on this last topic, emergency alert and warnings. Why do I dwell on that here? Because we think it's a nice and important complement to SRTI. SRTI is strictly focused on sort of what's going on the roads. But if you take a step back and look at sort of public incidents of a grander scale, they also have an impact on traffic. So the question was, how do we reach travelers in case of public large-scale emergency that have more than impact on traffic, but also impact on traffic? Flooding in Germany was quite a crisis, and yeah, handled in a, if I dare to say, suboptimal way. Could have done better. An example, a hostage situation at the main railway station in Cologne, which created, I mean, chaos, also impacting on all sorts of traffic. So we came up with this EAW specification. It's available free of charge. You can go to our website and request it, no strings attached. It's built on CAP, Common Alerting Protocol. So the two are, I mean, really compatible. And you can use emergency alert and warning to alert drivers in a way that can be digested by navigation devices. So say you're a foreigner traveling in a different country, and say a French person going by car to Germany, and then you have something like Überschwemmung or Flutwelle. What the heck is that? I don't know. How does it impact on my travel? Well, I just keep going. It can't be that bad, yeah. And then you hit a problem on the road. So we wrap this in a way so that the navigation device can actually process it and actually derive instead of getting stuck here, derive a route around the affected area. Plus, we leverage on the language feature of TPEC, where you can provide translation tables so that a French-speaking person would get the appropriate French term of flooding or whatever the issue is. Yeah, so that's pretty much it. Thank you for your attention. Any questions? If not, I'm hanging around, so feel free to come forward.
It was very clear. And what we can see with this presentation is that giving alert to the driver is something very important for a road operator point of view or emergency services. But some have already done the work. And so giving the first outcome in that X2 with the guarantee that the translation among standards will be done in a right way, then at the end, the proper services will run, is the most important thing, and that is the reason we set today in this room. Now, I will thank you, Matthias, for this presentation. Now, we will give the floor to Professor Stephanides, who is in Patras, University of Patras. And thank you, Thanasis, to have made the link with Professor. Welcome, Professor. We are happy to see you. We thank you for your presentation of shockwave damping how that X2 information can be used also to give some alerts and linked with safety relative traffic information, and how it is managed now in Greece. So I like to use the floor, Professor, and thank you to be there with 1 hour advance, because in Greece it's already 10, more than 10, but thank you to be there.
So thank you for inviting me, and this is a good opportunity to share with you some of the work we are doing in Greece. We are going to discuss today the work that we have done and are doing in Greece, specifically in Attiki Odos motorway, in the application of shockwave damping. So just as an introduction, let me just indicate that this is part of the project Sea Roads that started in December 19 and officially will end, unless there are extensions, in December of this year. There are 4 implementing bodies participating, and this is a national pilot of day 1 and day 1.5 CITS services using the HCITS G5 and cellular communications technologies. Okay, so we are discussing shock waves. Shock waves is a common phenomenon on highways. It is non-recurring. In other words, it is not easy to predict. It is not such as recurring congestion. It relates to non-recurring disturbances, and they can spread to vehicles all along the highway. I have here a little picture indicating that anything can happen, and a queue starts forming without really being it necessary to be in congestion. The queue starts forming behind the stopped cars, and the cars in front can leave. In fact, the car that has produced the whole phenomenon can leave and go home, but the queue can extend and can even result to accidents where some other car may be penalized for this event. Therefore, here we are talking about the need to damp shock waves. So the aim is to detect the shock waves as they are ready to develop, or if they have already developed. So in the last case, we can damp. In the case that they have not been developed yet, we would like to, if possible, avoid them. So how to do it? The way to do it is by communicating messages to drivers. There is a lot of data processing for this to happen. We have been, as a University of Patras, where we actually focus on such activities. We have been collecting, in this case, traffic data from Attiki Odos since September 2020. But as we all recall, during these events in the last 2 years, there were diminished activities on the roads. So initially we could not validate the data. In other words, we did not have shock waves, which is okay, it is good in a sense, but actually it is the result of not having enough traffic. Actually we started receiving information from queues in May of 2021. But in the meantime, we worked to create 2 algorithms. One is the shockwave watch algorithm, and the other is the shockwave warning algorithm. Watch is the case where the shockwave has not actually occurred. And warning is the case where it has occurred even for a moment. And so the messages that we send to drivers are a little different in this case. Therefore, in the beginning, we had to work with data from equivalent conditions, such as very dense traffic. But there was not enough congestion. Therefore, the period of collecting data was shorter, but we still keep collecting data even after having developed the algorithms. To give you an indication of the setup in a situation like the one we're discussing, here we have a portion of any freeway, any motorway. In this case, it is Attiki Odos. We have the intention of using the roadside units, RSUs, to communicate with OBUs, or onboard units, at specific cars. So we don't want to alert everyone, but we want to alert only the cars that are moving in the alert zone. The alerts, as we just discussed, can be either watch alerts or warning alerts. So here's the architecture of the system with which we work. Initially, on the left side, we have the Attiki Odos TMC, and that's where all the information arrives from the road. We're not involved in this part, but the TMC, then this is the critical element. The TMC has to communicate with the other operators, and in this case, this project has started with this part of the communication. So the TMC communicates, sending information from them in a DATEX2 format, and this is information on traffic. These traffic data arrive to the server of the University of Patras in this format. So we use the DATEX2 format for this communication. At the server of the University of Patras, we have a translation of what this information means. So we have to translate what we understand by analyzing it from the DATEX2, which is very convenient. And then we produce alerts in JSON, that shockwave alerts that we already discussed, and go to the national broker, which is the Center of Research in Greece. And the national broker sends information for in-vehicle treatment, and they send that information to, they could send it directly to the roadside units, and then that information would be taken to the onboard units and then to the human-machine interface. At the moment, they send this information, these shockwave messages, to the national access point, which is situated at the moment in northern Greece, and then the national access point sends the shockwave messages to the service providers. Any service provider can receive this information. In this case, of course, the most interested service provider is Attiki Odos, which then sends shockwave messages to mobile applications, and this is an experiment, a pilot, let's say a pilot that has been already running, and as we speak, it is also running. It has started running some months ago. Okay, so this is the architecture of the system. And there is a question, of course, why would we use DATEX2 in Attikiodos? But okay, just for the sake of completeness, we should say that it's a standardized way to communicate traffic information between traffic centers, service providers, and traffic operators. And by sharing these data in this format, Attikiodos gains the harmonized way to exchange the data across boundaries at the system level. And this is actually the aim of the project Sea Roads as it relates to Greece. Okay, so this is a data input for the shockwave watch and warning algorithms, which has to be communicated in DATEX format, and it relates to typical traffic data, such as the number of cars on the road, the volume, in other words, in over a specific time period, the volume, and okay, it could be the trucks as well as the principal elements of traffic, which is other than the volume, it is also the occupancy on the road and the speed of the road, and this information comes from a number of detectors on the motorway, which includes primarily loops, although cameras are also available on the motorway. This is just to give an idea of what we do with this information. The information on the left, you can see the number of cars, number N, the occupancy, and the time mean speed goes through a neural network, and that neural network produces the watch and warning output. Okay. Also important is that we have to follow, as the system works, we have to follow in real time the performance of the system. And for this, we use a number of indicators, but I will just, for the interest of this discussion, I will just tell you about two indicators that we use to monitor the performance of in real time. One is the detection rate, which is the number of incidents that are correctly detected divided by all the incidents, and the false alarm rate, which is the number of false alarms divided by all the alarms that we receive that we just discussed before. And of course, some of this information is available later, a little later, after we know what the incidents are. The content of the JSON files that I mentioned earlier include, of course, this information on watch and warning situations, and this is what we use in the next steps of the process. Here, I just want to show a couple of pictures of what the performance looks like, and what we have is we have to discuss what we mean by, as we just discussed, detection rate and false alarm rate. They could be anything, and we have to have thresholds that tell us that something is indeed an incident, or in this case, a shockwave, or not. In this case, it could be a shockwave developing or a shockwave that has already appeared. So on the left side, we have the work that we do with thresholds on the watch case, and on the right, on the warning case. On the lower side, we see the detection rate and the false alarm rate in one together. So we can see that, of course, as we know, if the system becomes more sensitive, depending on the threshold that we have produced, then both the detection rate and the false alarm rate will increase, and you see the change in performance is steeper on the right side, on the already detected alarms. And finally, I will show you also just one example of how we work continuously in real time. In this case, we work with these results by experimenting with the persistence. In other words, as we just discussed, when do we believe that something has happened, although these messages have appeared through the system? How patient shall we be in order to decide that indeed here it is that we have something? And this is what we call persistence. And here we can see that this detection rate and false alarm rate performance is indeed a function, not substantial, but important function of how do we persist in acknowledging this information that appears into the system, which as recall originates from the motorway in the first place. So this is what I wanted to present today, and I just remind that all of this work is done within the effort to make it more possible to have connected ITS, but the information, the messages that we exchange are in fact more or less the same messages that we would be using when the systems is more automated as we work towards autonomy, and the system would exchange messages with a machine rather than a human. So this is my presentation. I think I can stop sharing at this time, if possible. Let me see how we can do that. Stop sharing. Okay. Okay. Thank you very much.
We thank you, Professor. It was very interesting, very clear. Is there some question in the room? One question for Professor? So for me, it was totally clear what you say. And I much appreciated that the connection with C-Roads, with CITS, and how we do not forget other users so long all our vehicles are not equipped with CITS. So, and that is also something very important. And the detection also of shockwave damping will help to prevent rear collision. And that is also something we learned from the past. When you have congestion appearing, the major risk is to have rear collision. And if people receive information 300, 400 meters before arriving at the place where you have a intense brake or slow brake, it will prevent the risk of rear collision. So thank you. That is the link with SRTI. And thank you, Professor, to have been connected with us today. And we leave now the floor. We go from the south of Europe directly to the far north, because the presentation now will be done by Paul Harresund from Norway. He will present how SRTI is used by the National Road Administration, and I leave you the floor. I will not present you because yesterday all people who are in the room were already there, and you have present yourself.
Yes, thank you very much. So, still good morning. I'll walk you through some dissemination tools we use for SRTI messages in Norway. It's based on the DATEX node that we have in operation at Norwegian Public Road Administration. So it's going to be a lot of pictures and not so much text, so should be quite easy to follow. I'll go straight on. This is some, I would say, repetition from the opening session last So I can do it again, maybe? Well, no, I'm not going to read this. But DataX is the E language for traffic information. That's what it essentially says. So I'll just move on. Also, we have been presented with the priority action C, which is the SRTI messages. Just for completeness, I repeat them as well. We have 8 categories, and we also delivers on all these 8 categories. I'll come back to that. But these are the 8 categories for the SRTI messages in the delegated regulation 886/2013. So we have followed the guidelines from TISA. I was a little bit unsure if I had the last version, but it seems like I did. So I'll talk into the mics. Oh, yeah, I can look there. Thank you. So we have used the guidelines for the SRTI issued by TISA. And in 2019, we had a big revision from the Road Supervisory Authority in Norway that approved what we are delivering on SRTI messages today. And we actually delivers now on the whole main road network in Norway on all 8 categories at best effort. So that's a change from where we started, when we just had the Trans-European road network and 5 categories. So I'll move directly on to some of the tools that we use. This is the actual national portal for traffic information in Norway. It's hosted by the NPRA, and is where you see all the traffic informations for the public. This is also a responsive solution, so you can use it on your mobile phone as an app. This one is showing that you can, on the left here, turn on different layers. And this one is showing actually a traffic accident. And you see that it's opened and it's here. So all the colored items are active and the gray ones are planned, future ones. I also brought this one. We have a CCTV extension. So we have published cameras and some road weather information from the cameras. It's around 500 of them along the road network. Mostly of them are on road weather stations, but some of them are free and only set up as a camera. We actually show video here as well. So it's 1 frame per second video, so it's kind of a slow video, but it actually streams quite well also on slow platforms. This one is the tool we use to verify the DataX publications we send out. So here we also have actually brought in the Swedish ones as well. So we see the Swedish traffic information along with the Norwegian ones. We are not using linked open data, so this is, here we are consuming 2 different DataX services and show them in the same solution. And you can see that down here we have an option called Show Only Security Related, which is the SRTI messages. So if I move on and switch on that filter here, you can see all the ones that was currently an evening, I think, that are SRTI related for the moment. So we can verify that our messages are actually authentic and that we have distributed them in the correct way. And so, yeah, and I can also show maybe this one. This is an SRTI messages. It's there, and it's a rockfall. We have some of those in Norway. Big rocks fall down to the road and simply blocks the road immediately. And it's always a challenge to get that information soon enough out to the public, but this is how it's distributed when the road operators catch the incident. We publish them right away. Then you can see that we can actually also see what kind of DATEX-related information is associated with this incident here. And we can also view the XML, JSON. We also have a JSON publication and some more formatted DATEX information. I'll just show the XML here. So this is actually the XML for that incident. So they are broken down to situations, so we can see each situation for each incident. So it's much easier to verify that we are distributing this in the correct way. You see that here that this is a safety-related message also in DATEX. This one is something we have been working on. These are road forecasts for the entire road network in Norway. This has not been published, but in recent weeks it actually has. So now the public can use it. These are road forecasts, so that means we have a weather forecast, and then we have an energy balance model, so we can put the weather down on the road segments, so to speak. So it looks something like this. We can actually then, in a 4-hour prediction in the future ahead, it's a gliding window, so it updates every hour. It's always 4 hours ahead. The segments are divided into 500 meters to 2,000 meters. It depends on the variation in the topography, how long they are. But then you can see you can get forecast predictions on wet road, windy, if it is snow, or if it's ice or frost. I'll show that one here. that was a small area I found that was predicted with ice. And when it's real bad weather or undercooled rain or situations like that, then we have a purple. Our intention with this is, of course, to try and see if we can generate automated situations from these forecasts. They are actually now published as an elaborated data publication, as segments. And in the same measure data publication, we also have the road weather stations for the whole country. It's around 500. So what we would try to do, you see here, I've chosen one of the segments up here, and you can see that you actually get kind of a rate for how accurate it is. And you can also see the road surface temperature, which is minus 0.7, which indicates that it could be a dangerous weather situation on that segment. So what we would like to do is to take all these segments into some kind of machine algorithm to analyze it, and then publish certain situations, weather-related situations, based on how this is developing when it's bad weather. So that's an SRTI automated generated situation that we are aiming at. I'll just briefly show the DATEX node also. We have source system on the left side, which are publishing data to the node itself. On the left side here, all these systems are delivering payloads in version 3.1 of DATEX today. So I remember it was a transformation session yesterday about XSLT. So what we have done is that we have transformed it the other way from 3.1 to 2.3. So we have both running. So we can shift the, I would say, customers to the 3.1 in 6 months window is what we're aiming at. That will be Martin and Ari's problem to solve that. We are actually in a new TMC systems, which is now in production. We have developed ourselves in collaboration with the Swedish Transport Agency. it's actually based on DATEX inside as well. So we use the model actually in the incident management system directly. So that means that everyone is now sending a DATEX payload directly to the node, which is more like an exchange, telephone exchange, that consumes publications and distributes them. I'll go directly here. So, and then on the right side, you see some of our consumers. We do some big data analysis with the tools we have based on DATEX, the media, of course, and we have a map service. It's based on the OGC standards that you can actually consume as well. And, of course, the service providers. I think we have around 500 different users on the node at the moment, all from actually Google, which is there as a user, and down to some small skiing facilities, which are monitoring 2 weather stations maybe. So it's a wide variety of consumers, which actually pushes us into the end user problems actually. So that's something to discuss. I'll just briefly say that it's running on version 3.1. We have a transformation down to 2.3, so consumers can choose whether they go for 3.1 or 2.3. With the meta pilot discussed yesterday, we will move on to 3.2 or 3.3. Yeah. We also have a REST interface. In addition to the SOAP, we merely just publish the SOAP publication directly on REST as well. And on that REST service, we can apply filters. And as you see there on this third bullet here, you can actually then get the situations which are SRTI related, for instance. This is the OGC service I was talking about, which is VFS, VMS based. And you can use CQL filters to directly filter on those if you want to. Same filters you can apply here. And of course, these are more documented in the national access point in Norway, which is here. You can see that we have some more filters as well. And these are all of them that you can apply. So, and this is of course because the demand to the consumers doesn't want everything. They don't want a big payload. They want to be able to filter out what they need. So we have gone that path now, and we will see where this ends. The last one I want to show is the CITS pilot that we did with SRTI messages. I'll just show one of them. So here we have actually a kind of CITS scenarios that a lot of people these days use. We have a slippery road that we wanted to detect. And then we want, let's see if I can get that one. Yep. This car detects a slippery road, and then it sends it into the DATEX node. So we actually have some exposed endpoints that can be put from an external provider. That's what they've done here. And of course, that car will warn the other one in a CAIT fashion way. And of course, we can publish, so everyone get the message. That's the scenario we are working against now for the future. So of course, we need some data from the cars as well. And we hope that the car manufacturers will be able to provide connected data, because this will depend on that. We have done some work with Volvo in recent years, but that's only one car manufacturer. So I'm going to show briefly what we did. We took one of the service cars at the NPRA. We mounted an onboard unit directly connected to the CAN bus of that car. We then programmed that OBU to what should be slippery road. So you see that we need to have a speed, and we need to have some rounds per minute in the engine. for this message to be produced. So it will trigger a Denim 6.5 through a roadside unit that was mounted on one of the ceilings of our service providers. And we took in this Denim 6.5 message based on that algorithm up there, which is programmed in the OBU. And then we mapped ICE on road directly through a service provider's server that we have been used in some research projects, like the E8 Borealis, if those are familiar with that corridor test in the north of Norway. So we reused that server actually, that we already had. And we pushed that Denim message into, and we mapped it to ICE in DataX. And this was actually then also shown in the tool I showed you. So we could see that it actually came in as an incident. We also tested congestion, stopped vehicle, and wrong way driver with this pilot. So we are aiming at, the headline here is that we are aiming at some more automated situations based on data that we now have in provision. So we can generate them. That's the goal. And that was all, actually. Thank you.
So is there some question? I have a remark.
Yes, I have a question.
Yes.
And this road weather things, are they under fully control of the NRPR, or is there some weather service?
Some weather service is providing the meteorological model,
Okay.
and they are also running the energy balance model. That puts the weather forecast down on each road segment. Okay. Yes, but it's NPRA that is funding it and have the responsibility for the operation. Yeah.
I have a comment on on the comparison all messages versus SRTI messages. I personally believe that this is what it should be. Yeah. You feel inclined to like, oh, we have more SRTI messages than you, so we are better. No, I mean, it should stick out. It should be just the rare events that are communicated as in the SRTI context.
Exactly.
You shouldn't try to make as many as possible SRTI messages just because you think it's cool. Or the more you have, the better. I mean,
Exactly.
it should really be focused on the rare situation that are really exceptional and where people are caught by surprise. I mean, if it's cold outside and it's raining, people may expect the ice, but if it's unexpected, things like a rock fall.
Exactly.
I mean, that's something you don't like wait for it. Yeah.
No,
So I think you did it right. Yeah.
Okay,
That
thank
when
you.
you filter on the SRTI, it's just the very few, very severe things that show up.
Yeah.
So I like that very much.
Okay, thank you.
We need to talk more often, Paul.
Yes.
Because it's very I have a lot of remarks and experience that we share commonly because
Yes.
we are working on this kind of services and service integration as well, of course. But a DataX-related question I have is, you told us that the system is DataX2 native,
Yes.
but DataX is an exchange protocol.
Yes, it is. But
And did you, what was required to make a database model of it?
well, what we did is we created a kind of a mapping that can be configured. So we have this administrative client, and you can open and you can choose all the DataX elements and map them to incident types that the operator can choose from. And of course, all the metadata concerning the incident itself is stored in more document-based model, which is, I would say, an addition to DataX.
Yeah.
but we'll link them on the element level. Yeah.
It could be worthwhile that we share that kind of experience.
Yeah, exactly.
In more technical detail.
Yep.
Because I think we will see more and more native systems, and we could learn from each other there.
Yeah, absolutely. And since we are using microservices now in the back end, they are responsible for each little part of the domain. So
Can be done easily.
exactly.
And very
Yes.
dedicated.
Yes. Different storage methods. I mean, yeah.
So thank you.
Thank
Thank you, Paul. We have just time for the last presentation.
Okay.
I will just emphasize what you say. Armis, the first meeting time we met with Carlos, it was in 2009, and he built the first system, the first development based on DATEX native. And now we know that Armis is a big provider of system for the management of traffic and road operation in Portugal, but not only in Portugal. And so I think that we have to, and what I will also retain, but because it's a problem we will have in the near future in France, you have developed DATEX 2.3 to DATEX 2 3.1, and the opposite, and that could be interesting also to share.
But that's in the other session. That
Yes.
has been addressed. That is available.
Yes. So I will let the floor to Philippe, Philippe Meunier. Philippe is working in the team of Sylvain Beloche and Marie-Christine. As they are managing the whole French system, we know more with Bison Futé. And he will present how they use the Bison Futé for providing SRTI. He's the engineer for the French ministry.
Yeah, thank you. Good morning. I will present the use case TP. TP is a web-based application for managing roads, and it's only used in internal network of a ministry. It's not a public application. I will present you the TPIS, how data are processed by TP application, how is implemented TP in the managing center of roads. Sorry to hurt your hearing. It's and how information are pushed on Bison Futé national access point, and also in internal portal for in InfoCentre for traffic jam curve and working on how could be the traffic in the future, in next future, in the next months, next weeks for public information. And with the perspective and future development, because this is a DATEX in 2.3, and we are not also in 3.0, and maybe it's a future development you can choose for the next time. Also, the TP is a web application since online since 2010. Data collected are real-time traffic, events, traffic level, flow, occupancy rate, and that we call QTV, speed, like debit color. We call debit color because this is a traffic flow. The data come from Interdepartmental Road Directorate and also motorways company. We have a private motorways company like AOEA, SANEF, and we can publish make publication on Bisonfute for users by a traffic color map with the accident, works, lane closure, and also information can be used by the public. And we push the data on the national access point for Action Bay or C for private operators, for example, and Action Bay especially in that text too. And also we push communication with the media of press release. We have a lot of subscribers like public bodies or prefectures, national entities, and private and road operators. I will make a feedback on this subscriber. This is the presentation of TP. We have we can manage what we call regout months. This is our events are managed. We can in this this is for the winter, and also there is main difference of visualization and our manager data flows. It comes from the world manager and station, especially the automatic station on the roads. It go to the in the text format in the TP application. The TP application send data to the public website Bisonfute, and we can also publish website in the this provision of traffic and maps traffic. And TP send data to the Afonson statistics. We can make traffic forecast for the next week or next month, and also produce traffic jam curves. Traffic jam curves are used to for the team who are making a traffic forecast to try to prevent how traffic will evolve and in the next month or next week. We also get information from the operators, not by automatic way. Is the automatic way, and also operators can put information or put traffic jams manually. This is the repository for the TP information world. Repository is uploaded every 6 months. Also, there is another repository that can not use for the next years. You can stop next years for briefly use the repository of a national RRN, the national network. And Isidore is a tool for the patrimonial network. This is for how is composed the roads. Right? You can go deeply in the roads, and it gives information of the composition of the roads. This is a focus on the center of exploitation in the departmental directorates. TP is used by all the 11 DIRs, all implemented in French territory. There is almost 580 connected users, more than 20,000 kilometers monitored. Alors, only 10,000 on national network and 10,000 on the motorway concessionary network. It can treat 1 million events per year. There is not 12,000 subscribers. This is an entity who can receive information, traffic, really information of winter, how roads are open or closed, and for the NAPCO, the NAP point, 1,500 traffic measurement points on the panel. Only 10 deals. There is missing the biggest deal in Paris because he is not sending data in the DATEX mode. But we are pushing for evaluating this. The visualization on Bison Futé. There is the provision of traffic. How can you travel in the next time? Also the visualization of events and the traffic jam. You can push. You can have a zoom on each city. The main city are on the map, and also the national access point is showing on Bison Futé. We are presenting the ITS directive with how is are pushing the data, and here in open data mode for the center of managing traffic. There is the file in DATEX, the repository only by CSV mode, and there is a traffic speed data. We push this file every 6 minutes, and also for the repository. And we have actually currently 1,500 measurement points. It covers quite 3,000 of network roads. And next, I show you how is pushed the file and which information are allowed by the motorway company. Here we have the speed and the vehicle flow rate, and on the motorway company wants only traffic status value. They don't want to have the speed on their motorway. They don't have the vehicle flow rate. We have two different flow of information for the national producer, the state producer, and the private producer. And we also produce traffic jam curves. This is pushed on internet web, on Bison Futé website with level of traffic actually currently level of traffic, and also historically the most elevated level of traffic, and in occurrence in the time they are unusual or low. And we can make a focus on a speciality like Lyon. We can see that the traffic is not very high, and this is we can show that the particular point they are automatically stationed who are sending, and some stations are not very good formatted, as we can see. They can confuse no traffic and traffic jam, and so we treat as you can to make difference low traffic or traffic jam, because station don't make difference because no occupation and traffic jam. This is our private tool for traffic jam curves, and we have more information than public site. It's more rich. We have especially day for to compare to make a comparison between the day and all specific day that seems like traffic jam this day. And operators, we can choose here a specific date to see how was the traffic at the date, almost 10 years. It making the more and more quality data. When data are recent, they are more quality, because 10 years we have not very good information. And also we can choose a specific town, we can choose a geographic town, country, and also we can visualize on the national territory how is evolving, how is it growing traffic, and we have a different level. And also we agglomerate national level with different countries. Those countries are corresponding of the bison futé sectories for publishing information of different traffic jam. And so in the future, what we could make, as I said, currently one road operator is missing on national territory. The direction of Paris only send XML flow. This is not DATEX. The motorway companies, we have only 3 companies on 20 who are providing data for the NAP bison futé. And we can also add local authorities data, because small cities, departmental and secondary roads are concerned by the action bill. And also migration to the web service, because all the data are coming with a FTP mode, and we are attending to migrate to the web service mode. There is on travel time data. For now, there is no data on NAP bison futé. We are making TP ready for data processing and publishing these data. And also we have to make to improve by localization file in DATEX mode, because we have only CSV file, and this is the next steps to publish those data in DATEX mode. This is almost the main evolution we can attend. And also this is the thank you.
Thank you. So we finished on time, but it's perhaps also some question if you want. You have the occasion to. I will just emphasize that it's a big difference between providing measurement information from a motorway company private and a public one, because if you know the flow every 6 minutes, you know how many vehicles are passing there. If you know the category, then you can calculate the income. And if you go to bourse, you can buy or sell your part of, if you are part of the owner of the company. And so that is the reason it's not giving in real time. So giving open data is a good idea, but sometimes at side effect, which makes that is not possible. So that is what we do in France. We see that some are in advanced, so we will learn from you. Thank you to all to attend this session. It was early on the second day, but thank you to be there. And I think it was very fruitful. And now we have a small coffee break, and then we will have some pitch to speak all together on the future of DATEX. And Bart will be manage this session. Thank you, Bart.